So today we're going to talk about the centroid theorem, but before we get started on centroid theorem, I need you to draw that triangle in your notes. Because I'm not going to write down the definition of the centroid theorem, or I'm going to explain it as we go. Okay? So if you'll just draw you a triangle in your notes, draw it rather large. Okay? Don't draw a little bitty tiny one. Draw a pretty good size one. Alright? And label that triangle just like it is. Okay, and I'm going to start as y'all are drawing because I think you understand what some of these things are. Okay? Alright, so a triangle's got three sides. We all know that. A triangle's got three angles. We all know that. Okay? And where two sides come together, say side AB and side CB, where they come together is called a what? Here, I'll help you out. It's called a vertex. Okay? So a triangle has how many vertexes? Well, if it's got three sides, it has how many vertexes? It has three vertexes. Okay? So you got a vertex here and a vertex here. Okay? Alright, here's what I want you to do now. On each side, side A, B, B, C, C, A, I want you to mark, put a dot at the midpoint of that side. So for instance, BC, midpoint is about right there. I want you to put a dot right there. Okay, do that for each side. Just eyeball it, don't have to be perfect. There. Okay, everybody with me? And label those points D, E, and F. Okay, and those are midpoints of the segments. Okay? Alright. Here's where the lesson comes in. We are going to draw what we call a median. A median goes from the vertex of an object to the opposite side midpoint. Or from the midpoint of a side to the opposite vertex. So I'm going to draw a line from here to here. Do that all the way around. Okay? So I'm going to draw a line from here to here. Just like so. And again, this is called a median. This is called a median. I'm going to draw one right here. Try to make it as good as I can. That's also called a median. And I'm going to draw one right here. That's called a median. So we have three vertices, we have three medians, and we have three midpoints. Okay? Now, I want you to understand, this is called a median because this happened. When I drew that median, it cut this side in half. It cut this side in half, and it cut this side in half. Okay, so what I can say about BF and FC, what can I say about those two segments? That segment is congruent to that segment now. And this segment here is congruent to this segment. And this segment here is congruent to this segment. I did not say that all the segments are the same, just on the same side. So this same side got cut in half. So this is congruent to this now. Problem. I have a triangle here with a median cutting AB. CB is 6. What's AC going to be equal to? It's going to be equal to 6 also. Okay? What is AB going to be equal to? Well, what's 6 plus 6? 12. Okay? You see what I'm saying? That's how complicated that is. Okay? That is not hard at all, is it? Alright. Now, if you'll notice, when I drew these three medians inside this triangle, what happened? What happened right here? They all did what?
Connected.
They all crossed at what? One point, right? They all crossed at that point. That is by no accident. It is a natural occurrence that happens in all objects. Okay? This point is called the centroid. It is also called the point of concurrency. Point of concurrency. Let me explain what the point of concurrency is, because mathematically it's boring, but in nature it's not boring. The point of concurrency, or the centroid in objects, are the perfect balanced point. In other words, if we were to cut that triangle out, draw its centroid, then take that centroid and put it on a pin right here and hold it out, it would be perfectly balanced. That means it wouldn't tilt one way or another. It would be perfectly balanced. So it is a balance point also. Okay? Now, since we found the centroid, some things happen. Okay? Let's take this. I'm going to label our centroid G. The Centroid Theorem says this happens. There's four things that happen here with the Centroid Theorem. Number one, AG, everybody see AG? That's what segment I'm going to use. AG here is equal to 2 times GF. Okay? Number 2, GF is equal to what? AG divided by 2. Okay? Number 3. AG is also equal to 2 times, oh, excuse me, no. Yeah. 2 times AF divided by 3. That's G, by the way. And number 4, GF is also equal to AF divided by 3. That's what the Centroid Theorem states. Okay? And this is the short of it. Let's look at this example right here. All right, we're talking about segment RL, BL, RB. If LR, this whole segment, is 5.1, what is BR equal to? And how would you find it? Well, look at this. This whole segment here is 5.1. This is the short segment. This is the long segment. You know how I know that? Because that's shorter than that one. Okay? Over there, the Centroid Theorem says this, that the short segment, the one we're looking for, is the whole length divided by what? The short segment, here, the short segment, the long segment, the short segment is equal to the whole segment divided by what? 3. Okay? So to find BR here, or the short segment, all I'm going to do is take my handy dandy calculator, take 5.1 and divide it by 3 and tell me what you get. Everybody do that. What do you get?
1.7.
1.7. That's what BR is equal to. So BR is equal to 1.7. Now, using that, we can find what BL is. What's BL? It's the long segment. Well, if I got the short segment and I'm trying to find the long segment, what do I need to do to the short segment in order to find the long segment? Multiply by 2. So everybody take 1.7, multiply it by 2, and tell me what you get. 3.4. And I bet if you take 3.4 and add it to 1.7, you get 5.1. Okay? So all you gotta do is figure out where your short segment is and where your long segment is. That's all you gotta do. And then use that. Okay? Let's look at number 5 here. This says that CH is 20.6 and HU is equal to, I don't know, and CU, I gotta find. Okay? So here's what I would do. What segment is that? Is that long or short?
Short.
No, look at it again.
Do it again.
It'd be the long segment. Okay, I'm given the long segment, and I gotta find the short segment. So how do I find the short segment given the long segment? Did I multiply by 2 or did I divide by 2? I divide by 2. So everybody take 20.6 and divide it by 2. Tell me what you get. 10.3. All right. I'm not looking for HU though. I'm looking for CU. So I got 20.6 and I got 10.3. Add those two things and what do you get? 30.9. Is that correct? And that's what you get right there. I erased all the numbers on that one. Weird. Here we go. This segment is 3. Find what KT is equal to. This segment is 3. Find what KT is equal to. Well, what do you got? You got the short segment. How do you find the long segment given the short segment? How do you find the long segment given the short segment? Here's the long segment, here's the short segment. How do you find the long segment given the short segment? What do you do to that? You multiply by 2. What's 2 times 3? 6. Now I'm trying to find that segment, which is 6 plus 3. What's 6 plus 3? 9. So my answer is 9. And that's how complicated that is. It's all about seeing what you got, short segment, long segment, and that's all you got to worry about. Okay?